Hi there everyone, my name is Afan, and today I'm going to talk about the Pythagorean Theorem. So this theorem is a relationship between the sides of a right-angled triangle. So this was found by Pythagoras. He was one of the real first mathematicians that we talk about, and he was a philosopher too, and many of his subjects include people that were influenced like Plato, Aristotle. So enough with the philosophy. So he found a really deep connection between the sides of a right-angled triangle, and this connection is really essential to all the geometry that we do today. So today I'm going to try and show you the connection he found, and try to give you an intuition for the connection he found between the sides of a triangle. So go ahead, if you want to do this with me you can, and I'll give you some steps on how you can do that, but before that I just want to introduce this to you. So right here you see I have a right-angled triangle, the blue, right? I highlighted it in blue. So you have this side, and this side, and these two sides make a right-angled triangle right here. So that's pretty easy to understand. So I have a right-angled triangle. If you notice something, I also have squares that correspond to each of these sides. So this square here is the square of this side here. So I have this length here and this length, all these lengths are the same and they correspond to this side. I also have a square here and I have a square here, right? And they correspond to the sides that I have them attached to. So before we go too far ahead, us mathematicians like to label things. We just like to label things with letters. And why we label things with letters is because we want these rules that we find to be applicable to any right-angled triangle, right? So let's call this small side here, the smaller side of the triangle, let's call that A, alright? Let's call the other side that makes the right angle, let's call that side B. So again, this side we're calling A, this side we're calling B, and the other side, let's call that C, alright? So A, B, C, pretty simple letters to use. So I have this side that I labeled A, this side I labeled B, this side I labeled C. Pretty easy. Now before we move on, I want to talk about something else. And you see that I have squares attached, right? And when you saw the squares, you might ask, well, why do I have squares attached? And that's something really beautiful about mathematics. Two really unrelated things can become related in a really deep way, and that's the thing that Pythagoras found. There's actually a deep connection with these squares in this triangle, and I'll explain. So first of all, I'm going to talk about the area of these squares. So let's talk about the area of this square first. So the area of the A square right here. So what would the area of this square be? So area again is length times width. And what's special about the square? Well, the length is the same as the width, right? So what would the area of this square be? Well, that would just be A squared. Why is it A squared? Because A times A, right? That's the area of the square. You should be familiar with area of square, right? Not too hard to understand. A times A. So that's the area of this square. And how did I get this square? Well, I just made a square out of the side, the shortest side of the triangle. So A squared is this area of the square. So what would the area of this square be for B? Well, that would just be B squared, right? Because B is here, and then this is also B, so B squared. That's the area of this square right here. And what would the area of this square be? Well, that would be C squared, right? Not too hard to understand. I have a right-angled triangle, and I made squares for each side, and now I named the area of the squares. This was A squared because this side is A. This was B squared because this side is B, and this side is C squared because this side I called C. Pretty easy and intuitive to understand. Now, we're going to go here. And before I go there, I actually want you to do this with me. If you're interested, take a piece of paper and make this setup right here. So make a right-angled triangle. Could be any size. Make sure that it's a right-angled triangle though. And make squares for each side. So make sure this side, this side, this side are all the same. So make sure you have squares for each side. And go ahead and make this. You can pause the video, go ahead and make that. Okay, so if you've made that, go ahead and cut out all of these shapes. So you should have 3 squares, right? And you should have 1 right-angled triangle, and each of the squares should correspond to the side. And now that you have those 4 things, right? You have the 3 squares in the triangle, set it up like this. I know this is a little bit small, but hopefully you can see it. So your right-angled triangle should be in the middle, again, just like that, but all I did was I rotated it, so the C should be like this now. The C should be horizontal just like this. Now that you have your triangle set up again, go ahead and put your squares. So a goes with a squared, b goes with b squared, and c goes with c squared. Go ahead and do that. Okay, we've done that. Now comes a fun part, and a little bit of a tricky part, but don't worry too much. What I want you to do is take your ruler that you're using for this thing, or if you're just watching, that's fine as well. So take your ruler and line it up with C, right? So I lined it up with C, so the left side of C, right? And notice how the ruler also goes into B, right? What I want you to do is make a line on B that is following the ruler. So just make a line like that. Now it doesn't look perfect or anything on B. It looks like a pretty random line on B, right? But what I want you to do is make that line. So imagine that C continued and just draw a straight line like that. Draw that line and draw another line that goes like this. So start at this diagonal where the B touches A and the triangle. So start there and draw a straight line. So just like that from this, start from this corner where it touches A and the triangle, my bad, this corner, and draw a straight line like that. Again, now you should have something that looks like this for B. Maybe I can take it off and show you. So your B should look like this. And again, I showed you how to make it look like this, right? Now what I want you to do is actually cut on these lines, okay? So go ahead, cut this, go ahead and cut that, okay? Once you're done cutting that, you should have 4 pieces. 4 pieces that look like this. You have 2 triangles, so one bigger than the other, and you have 2 trapeziums, one bigger than the other. Now what we're going to do is we're going to find a special relationship. Look what I can do with these 4 pieces, okay? So you should have, again, 2 triangles, one big, one small, 2 trapeziums, one big, one small. So what you want to do is take your big triangle that you have, line it up on c squared like this. Alright? So again, I'm going to move c squared here, it's just c squared. What I'm going to do is I'm going to move c squared there. So take your big triangle that you got from b squared and line it up like that. Now, take your small triangle that you got from b squared and line it up as followed. My bad. Line it up like that. Alright, so you took your 2 triangles and you lined them up like that. Now take your big trapezium, and I am going to just use, here. I'm just going to use this magnet here. Take your big trapezium and put it right there. Alright? Okay, so we used 3 pieces from b squared. Now we should have 1 more piece left. And the 1 more piece goes just like this. So what I'm going to do here, I'm going to take this, sorry, my bad. So again, I took the 4 pieces that I cut from b squared, right? And I lined them up like this. Wow, that's something special. There's a square that's available in the middle. And guess what? Do you know what square can fit in right there? A squared fits in perfectly. Look, a squared would, let me just show you that. Look, a square fits in perfectly. So what did we find? Well, we found something really special, didn't we? We found that when we cut out b squared, right? So b squared looked something like this, right? We cut that out there, and we cut that out like that, right? We cut that out something like that, and we arranged b squared in c squared, and then we also put a squared in it, and it was equal to c squared. So mathematically, what did that mean? Well, a squared, right? We took a squared, and we added it to b squared, right? We cut out b squared. We added it to b squared, and well, what did we find? Well, it was equal to c squared, right? Because, again, remember b squared here, I cut it out, and I arranged it in c squared, and then I found that there was a hole in it, a perfect square was in it, right? And I put a squared in it, and it made sense, a squared fit in. So what we found was that a squared and b squared, let me just get rid of that. So what we found was that a squared plus b squared is actually equal to c squared. And this is really, really special because it's weird how this side and this side, when we take the squares of these sides, equal perfectly c squared. So if you worked with this and you did this, you would see that no matter what size right angle triangle you had, it worked out. You actually fit b squared and a squared in c squared. So that's what Pythagoras found, and it was really exciting during his time because he found that for any right angle triangle, you can take the squares of the sides and you can add them together and they fit perfectly into c squared. Like, they fit perfectly into the hypotenuse squared. And it's a really deep, really profound theorem that we use in geometry all the time. So imagine we had a right angle triangle, and we had this side was called 3, and this side was called 4, right? But we did not know this side, and well, we did not know how to find this side. But now, using this logic, using this theorem, we found that the square of this side, right, and the square of this side should always fit in or equal the square of this side. And that's what Pythagoras' theorem is. It's a deep connection between the sides of a right angle triangle. So I'll try and put up a animation right now of the same thing, how this square and this square can add up to this square. So maybe I'll have the animation playing right now if I can get that working. If not, hopefully this taught you about the Pythagorean theorem and what it actually means, and now you really should be able to know what it means. Instead of just saying a squared plus b squared equals c squared, well, what does that really mean? Well, that means this square and this square, if I put them together, actually equal this square. And these squares come from the sides of a triangle, a right angle triangle. So if I did the same thing on this triangle, I would find that the square of this side and the square of this side would fit into the square of this side. So again, that's Pythagoras' theorem. Hopefully this visual helped out and now you know how that works, and I'll try to put up an animation again. And again, thanks for watching, and hopefully that helped you out.